One user asked your server for a sorted report. While that report was being built, every other page on that server took 2,900 milliseconds. The same page normally answers in under 1 millisecond. Nothing was broken. No error was logged. The machine was not out of memory. I also put a checker in front of it, something that asks, "Are you alive?" and gives up after 2 seconds. While the report was building, the checker gave up 5 times out of 5. I measured all of that on one test machine, and I will show you every number. What the real system does after a checker gives up is a separate question. I will come back to it, honestly. By the end of this video, you will know why one person's request froze everybody else. You will also know the 3 ways out. Here is the picture almost everyone carries. A request arrives. Your server gives it a worker. Another request arrives and it gets its own worker. 10 users, 10 workers, all going at once. So if your code is slow, it is slow for that one person. Everybody else is fine. That picture is wrong. And it is why this bug is so confusing the first time you meet it. Your server does not hand out a worker to each person. It runs all of your code in one lane. One lane for everybody. So the real question is not how fast your code is. It is how long your code holds the lane. Let me show you the lane. Every request that arrives joins a line. The lane takes the first one, runs your code, finishes, and takes the next. That sounds slow. It is not, and here is why. Most of what a server does is waiting. Waiting for the database, waiting for a file, waiting for another service to answer. When your code waits, it pulls over. It steps out of the lane and lets everybody behind it pass. When the answer arrives, it rejoins the line. That is the whole trick. Thousands of people share one lane because almost all of them are parked, waiting. Now the other kind of work, sorting a big list, adding up a million rows, searching a million lines of text, building one enormous string. None of that is waiting for anything. It is thinking. And thinking never pulls over. It sits in the middle of the lane until it is finished. Everyone behind it stops, not slows down, stops. That is what the report was doing, sorting 12 million numbers in JavaScript inside one request. On my test machine, that sort took about 3 seconds. Every other user waited for all of it. Now the part that catches almost everybody. You have seen async and await. You have been told they make things run at the same time. So surely you just mark the slow thing async and the problem goes away. Let me measure that. I wrote a function that thinks for exactly 1 second. I marked it async. Then I started 3 of them together and waited for all 3. If they truly ran at the same time, that should take 1 second. It took 3,000 milliseconds. One after another, exactly as if async were not there. Because async does not create a second lane. It only marks a place where your code is willing to pull over. Work that waits has somewhere to pull over. Work that thinks does not. So async and await were never a fix for this. At this point, something should be bothering you. You have probably heard that Node is not really single-threaded. That is true, and the precise version is more useful. The official documentation describes 2 kinds of thread. One lane that runs your JavaScript, and a small side crew for a few expensive built-in jobs. That side crew is real. I measured it with password hashing. I asked for 4 password hashes the waiting way and started them together, 388 milliseconds. Then I asked for the same 4 hashes the answer me right now way, 900 milliseconds, no faster than doing them one at a time. Same job, same settings, 2 different doors. One door hands the work to the side crew and lets other people past. The other runs it in your lane. I checked that second door properly. I set a timer to go off immediately, then started one hash. 225 milliseconds later, that timer still had not fired. Nothing else could run. The documentation names both doors, and it tells you plainly not to use the blocking one in a server. And your own loop has no second door at all. Neither did that sort. Your own code has exactly one lane. Now back to the opening. Something out there asks your server several times a minute a very simple question. Are you alive? That question is the cheapest thing your server does. It answered in under 1 millisecond when nothing else was running. But that answer still has to drive down the same lane as everything else. So while the report was sorting, the answer sat behind it. Here are the numbers from that run. Normally under 1 millisecond. During the sort, 2,900. That is about 4,000 times slower for a request that does nothing. Then the checker, 2-second limit. While the server was idle, it passed every time. While the report was sorting, it gave up every time. 5 out of 5. That is the mechanism, and it is the part I measured. Now, the honest part. A checker giving up is not the same as your server being removed. What happens next depends entirely on what is watching it. In many setups, something decides that machine is unhealthy and stops sending it traffic. That traffic has to go somewhere, and the other machines are running the same code. I did not test any of that. No load balancer, no cloud checker, no second machine. I measured a checker timing out. The rest is what people report, and you should treat it that way. So what do you actually do? 3 options. Pick by how heavy the work is. First, break it into pieces. If the job is a loop over a big list, do a slice of it. Then deliberately let go of the lane. Then do the next slice. The whole job takes slightly longer. Everybody else keeps moving. In Node, the thing to type is set immediate. Second, give it its own lane. If the work is genuinely heavy and cannot be broken up, hand it to a separate lane built for exactly this. That is, worker threads. Your main lane hands over the job, stays free, and gets an answer later. Third, take it off the server completely. If the job takes seconds, it does not belong in a web request at all. Put it on a queue. Let a separate process do it. Tell the user when it is ready. That sorted report belonged in the third box. And one more thing which costs you nothing. Measure the line. Ask your server on a timer how long it is taking to get a turn. When that number climbs, you have found work holding the lane, and you will find it before your users do. Under 1 millisecond, 2,900 milliseconds, same server, same code, nothing broken. One person asked for something that thinks instead of waits, and everybody else stood still behind it. Your server was never giving each user their own worker. It was always one lane. The only real question is how long you are willing to hold it.